So here let's create a function encode where we will encode the given string using Huffman code. And now here inside this function, let's take a for loop for starting from 0 till the last character of the string. So let I is equals to 0 and go till I is less than str.length and I plus plus. And here inside this loop, we are going to store the characters as the keys in an object, a mapping object. So here we are going to take a mapping object. Let's call it mapping, and this is the object. So here in this object, we are going to store the characters in the string as the keys in this object and their count or their frequency as the value to that key, right? So we will check if the key is not already present. So string.char at I, if this key in mapping, if this is not already present as a key, then at the first occurrence of the character, we will add 1 to value at this key. So the key will be string.char at I. So this character will be the key and the value will be 1, as this is the first occurrence of this key. Else, if the key is already present, then we are going to increase the frequency or the count for that character. So at this string of char at I, at this character, the value will be, first we will fetch the previous count or previous frequency from this mapping, and after getting it, we will add 1 to it. So this will be the new value at that key. Now let's generate the tree. So here let's call generate tree by passing this mapping object, and let's create this function generate tree. And now inside this function, let's first get all the characters or keys from the map object so that we generate nodes for those characters. So here we'll say object dot keys, and here we will pass the mapping object. So this will give us an array having all the keys. Let's call it key set, and now we're gonna invoke for each on this key set. For each. So for each character or for each key present in this key set, do this stuff. So here as implementation, we are going to create nodes. So first let's create a class called Huffman node. So let's say class Huffman node. Let's create the constructor, and this Huffman node will be having the frequency, it will be having the data, which will be the character. So let's call it data, and it will be having the left node attached to it and a right node attached to it. So let's set up all these fields. This dot data equals to data. This dot left equals left, and this dot right equals right. Now coming back here in generate tree, let's create the Huffman node. So let node new Huffman node. So first it takes the frequency of the character. Let's get the frequency for this key. This will be mapping, and the value present at the character, and the data will be the character itself. And now For now, we don't have left and right to it. And now let's add this node in an array. Let's take array. I'm calling it priority queue because we are going to insert the node in this array according to a certain priority. Actually, we will insert the nodes in descending order of their frequency to get the smallest nodes at first. So let's push the node in this queue, and each time we push a node, we need to sort this list so that we can set up all the nodes in ascending order of their frequencies. So let's pass a b, and this will be a dot frequency. Now a dot frequency minus b dot frequency. So now we will have the smallest node at the front in this priority queue. So now let's do the merging of these nodes and create a tree from all these nodes. So let's take while, and here. So before start merging, we must verify that there are at least 2 nodes present in the priority queue. So let's check this, and let's say this must not be undefined. So now we are inside while, and here we are going to get the first 2 smallest node out of the priority queue to create the merge node. So this is the merge node. This will be new Huffman node, and first we need to get the frequency. So first let's get the first node from the priority queue, from the front of the priority queue. So this will be first, and let's invoke shift on priority queue to get the first element from the front. And now we'll get another element from this priority queue from the front. So this will be second, and again we will invoke the shift on priority queue to get this one. Now this merge node, so we are going to merge this first and second node. So the frequency will be the sum of frequency of first and frequency of second, right? So this will be frequency first dot frequency plus second dot frequency. And now as we don't have any character for this merge node, we will simply put hyphen. And now at left we will add the first node, and at right we will add the second node. And now let's take a root node. So let's call it root. This is root. And we are going to set the merge node as the root node for the tree. So let's take it here. Let's say var root. And now going back to the generate tree function, here let's push this merge node in the priority queue. So we have till now we have removed this first and second node from the priority queue, and we have added these nodes at the left and right of this merge node, and then we push this merge node in this priority queue. So after pushing this merge node in the priority queue, again we're gonna sort this queue according to the frequency. So let's say it again, a comma b, a dot frequency minus b dot frequency. So when this while will complete, we will be having only one node left in the queue, which will be the final root node, having all the other nodes attached in the branches. So this is the tree we wanted here. So here we will return it by calling shift on the priority queue. So here we got our tree, and now coming back to the encode function, here let's take it in root, or we can avoid taking it in root as we already be having this in the root, or let's remove this root that we have taken as global variable here. So let's remove this root. So we got the root or the tree. Now let's generate the binary code for all the characters from this tree. So here again we're going to call a function which will be to set binary codes. So let's call it set binary codes, and in this function let's pass the root, and we are going to pass an additional parameter which is a string, empty string. So let's create this function binary code, set binary code, set binary code, and here let's call the tree node. So we are calling it node, and here the string we are calling it str. So first here we need to check the node must not be null, right? So here let's first say if node is not equal to null, then do everything. So to generate the binary code, either we have to go to the left or we have to go to right. If we are going to left, then we will add 0 in the code, and if we are going towards right, then we are going to add 1 for that, right? So this will be string equals to string plus 0 if we are going to the left, and we will call the set binary code for the left as we're going towards left. So this will be node dot left, and we will pass the string. And if we are going to right, then we're gonna do the same thing. We will add 1 to the string and we will go towards the right. And now the base case is when we reach to a node which is not having a left or right. That is, it is the leaf node, right? So here we will check if node here node dot left is null, and also node dot right is null, then we can save the string generated for that particular character. So here we are going to take a variable, it's a mapping object. So let's take it const char binary mapping. So this will be a mapping of each character with its binary code, right? So here in this mapping object, at the key for that character, that is at node.data, we will put the binary code generated for it, which is stored as str. But this gonna result to one extra character, extra code at the end. So we're gonna slice the string from 0 to length minus 1 to exclude the last character. So here string will be string dot slice 0 comma str dot length minus 1. And same here when we are calling set binary code for right. So this is the code, this is the implementation. Now let's, after getting all the codes, what we're gonna do, we are going to generate the binary coded string for the string that we're getting as the input. So let's generate the binary string, binary coded string. So let's take a for loop. Let's say for starting from 0 to the length of the string I is less than str.length. This is the string that we are getting as the input parameter to this function for which we have to generate the binary coded string. So here increment I, and now here we will take a variable s where we will keep concatenating the binary code for each character. So we will get the value, the binary code for the character. The character is str.char@. So for this key, we are going to get the binary code and we will keep concatenating these codes to make the complete coded string. So that's it. And here, let's return this coded string. That's it. Now let's invoke this function encode. So let's take the string that we want to convert in the code. So let's take the same string, the one that we took in the explanation part. So this is the string that we took, and now let's call encode and pass this string to this function. So this function call will return the code, and here is the function call, str. Now let's print this code on the console. Let's say the final coded string is this code. And here, if we also want to print the char binary mapping, then let's print it here. Let's copy this and let's console.log it. So console.log. So this is char binary mapping, and this is the complete implementation. Now let's try running this program. Go to terminal, and here let's say node Huffman code. So we got an error, which is reference error. We haven't defined as. So let's go to that for loop. Let's go by searching this. This is s equal, yeah. So here outside this for, let's define s. Let's take let s blank string, and let's save this and rerun this program. So this is the result we are getting. We're getting 0, 0, G, 0, 1, A, 1, 1, 1, and the final coded string is this. So there was a slight difference between the codes for a few characters. For example, look at the F. In code, we got 1, 0, 1, 0, and here we are getting 1, 0, 0, 0 for F. This difference is because here these nodes 3 and 3 are exactly having the same frequency. So here we took this 3 node first, which is having 1 and 2 attached to it, but in code this D is coming first. So this D is coming at left, and that's the only difference. Everything else is same.